What up, fam? We're going to go into this complex numbers intro quiz review. This is my second recording of this, so apologize in advance if I go too fast. I had a massive microphone error the first time I uploaded this thing, and it like double recorded and then it screwed up. Whatever. I'm done talking. We're going to go on and get going. We have minus I, minus 5I, and that's negative 6I. What did I do there? We simply added like terms as if it's a regular old adding like term problem back in pre-algebra. There's really not much to it. However, there is one piece of information with these questions that we do want to start getting right. While I would give you credit for that negative 6I, it's a very good habit to get into always writing in A plus BI format, so you do not lose points on the questions that do have two different letters, because you would lose points if they're in the wrong order. We want to make sure we're writing these in that correct order at all times. So if you want to like really write it correctly, we do 0 minus 6I as our final answer. Likewise, on this number 2 here, we got 3 plus 3 that adds to 6 plus 2I. Really not much to it. We just treat these things like we're adding like terms. Let's move on to the next one. Question number 3. So on question number 3 here, it's going to be something we've done before. We're going to go ahead and distribute. So we're going to go ahead and distribute. We're going to multiply that negative 7 times negative 8. That's going to give us positive 56 with an I on it. And then negative 7 times positive 8 is going to give us a negative 56 with an I squared on it, because you have an I times an I. And this is where things start changing up a little bit, because the big definition that you start with when it comes to complex numbers is that I squared is equal to negative 1. That I is this number that when you square it, you get negative 1. And therefore, we're going to go ahead and replace that negative 56I squared with a negative 56 times negative 1, which is in fact going to be positive 56. In general, I skip this step in the middle. We're going to go straight from this step to this step when we actually do all these questions, but I just wanted to show you that's what I'm doing for the future. Please note, you got to make sure you write this in that correct order where you are doing that A plus BI format. 56 plus 56I for our answer there. And now one more thing with this. On all these problems, I'm going to go ahead and show you one thing you can do for every single one of these questions if you are so inclined to do so. And that is this. Do the entire thing on your calculator. So really quickly, sorry I'm in the weird screen right there. I was doing it in advance. We're going to hit the mode button. When you hit the mode button on your calculator, this little screen pulls up and we see the A plus BI right there in the middle. We're going to scroll down to that A plus BI and we're going to hit the enter button. So it's highlighted A plus BI. We're going to go and quit out of here. And this will allow us to go ahead and solve for us. So we do negative 7I. By the way, the letter I is the blue above the period. Be careful. It's not this green one over here. That one will not work. This one will. So seconds and then the little dot there, little decimal. So negative 7I parentheses negative 8 plus 8 times I. And sure enough, it's going to do all of the work for us and tell us that we got the right answer. You do need one step of work on these questions for that reason, because otherwise the calculator will just do everything for you, and I can't give you credit if you only throw it into the calculator. All right, so continuing on here, 5 times 8 times 2 is going to be negative 80, and then I squared there. So I squared is negative 1, so this is going to become positive 80, and then don't forget to write it in that A plus BI format. Nice and neat. Let's keep on moving. Over here, we're going to have just kind of basic old distributive property. Remember, when you subtract something, you are doing minus a negative and distributing that whole thing, so it becomes plus 1 and plus 3I. Yet again, the negative 3 and positive 3 will end up canceling, so we get 6 plus 1 is 7 plus 0I, and we are happy campers yet again. Moving on to number 6. So on number 6 here, we have the negative 4 minus 1 is negative 5, and I minus 3I is minus 2I. There we go. Cool beans. All right, number 7. So there are two ways to do number 7. There's the slow way and there's the fast way. So the slow way is to go ahead and rewrite this as negative 3 minus 5I times negative 3 minus 5I, and then just doing all the work, doing our first, outer, inner, last, all that stuff that you're used to doing on questions like this. And we would do the same thing. We're actually going to have to on question number 8. But on this one, you could do a nice memorization. The nice memorization is going to be this. If you go ahead and have anything with an I on it squared, so we're going to go ahead and take this as A plus B with an I on it squared. What that is going to end up being, using our formula, hopefully we remember from days gone by, of a squared plus 2ab I plus b squared I squared. Well, that is right there, -1 in front of that b squared. So in fact, this thing ends up equaling a squared plus 2abi minus b squared. So we can use this formula to make this problem nice and quick. -3 squared is going to be +9. 2abi is going to be 2 times 3 times 5. That's 30. So plus 30i. And then minus b squared. So b squared is 25. So minus 25. And that's a much faster way of doing this question. So we get -16 plus 30i as our final answer. And again, you don't have to use this formula, but it's a cute little trick to know if you're in the mood. All right, so let's go ahead and move on to this one where you can't do any tricks. You just got to go ahead and do the math. We're going to distribute out over here. We're distributing everywhere, doing our first, outer, inner, last, our foiling. So we have 8 times -1 gives us -8. 8 multiplied by -4 gives us -32 with an I on it. 5i times -1 is -5i. And 5 times -4 gives us -20. And now we got that I squared. We can go ahead and add our like terms and change our sign where appropriate, because -20i squared is the same thing as +20. And that makes this 12 minus 37i. Bada bing, bada boom. Let's move on to the next side over here. So this one of my favorite questions, is the idea of I being a cyclical number. What we mean by that is anything to the 0 power is equal to 1. And then anything to the first power is equal to itself. And I squared we just defined as -1. Now, if we were to multiply both sides of this equation by I, we'd end up with I cubed, because we have another letter I there, and -1 times I would just be -I. If I multiplied by I one more time, I'd have I to the 4th, which would be -I times I, -I squared, -1 of -1, which is +1. So what happens is after 4 iterations, this process repeats itself. I like to draw this as a circle. You start off with the value 1, and then when you multiply by I, it becomes just I. When you multiply by I again, it becomes -1. And when you multiply by by I again, it becomes -I. You multiply by I one more time, and you're back to +1. And this repeats itself every 4 times. Now, how can you actually do these problems quickly? The idea is you could simply say, well, this is I to the 0, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Because what you're really doing is you're just saying, well, if I multiply both sides of I again, I would get back to that 5, and you're just going all the way up to 37. This would take you a long time. To do this fast, instead what we're going to do is use our old school remainder idea. So we are going to go 37, and we're going to divide by 4. And doing this way old school version, this is going to be 9 remainder 1, because you go ahead and subtract 36, and you have 1 left over there. So there's 1 remainder, and that's going to be our exponent of 1, meaning this is the letter I. Now, what if you don't want to do this long division? Well, we can use our calculator in a nifty little way. What we can do is we can remember that since we're always dividing by 4, we can treat it like money in quarters. Quite literally, the word quarter means a fourth of, or to divide by 4. So if you have a 1/4 situation, you end up with 25 cents. And we can go look on our calculator, what I was just talking about there. If I do 37 and divide by 4, I get 9.25. Or in other words, I am getting a remainder of 25 cents, or a remainder of 1. So 25 cents is going to give us this letter I. I'll do this in another color here. We'll do it in, I don't know, how about like a darker color? How about black? Here we go. 0.25. All right, so we got 0.25 as that remainder, and then we're going to have 0.50 as this one, and 0.75 as this one, and this has no remainder over here. I'm just going to say no remainder like that. And in general, if you want to think about it as, maybe like lining it up this way, this one over here would be no remainder. So no remainder there, and this one would be a 25-cent remainder, and this one would be a 50-cent remainder, and this one would be a 75-cent remainder, and then again, no remainder. The whole thing repeats. Anyways, there's only one question like this on the quiz. I'm moving on with my life. Let's go on to question number 10. So on question number 10, we have -1 minus 5i minus I minus 4i. Looks like another adding like term situation. So -1 plus 3 is 2, plus 2 more is 4. And then -5 minus I minus 4 appears to be -10 with an I on it. We're all done with that question. Here we go. And we have just one long multiplication question. My big recommendation on a problem like this is to multiply the two things on the right first and then deal with the number on the left. And the reason why is to keep your numbers smaller. If you choose to distribute the 8i in and at first, please make sure you only do it to one of the parentheses, not to both. It's not like the 8i is going to both of these. It's just multiplying once in front. So you choose which one's multiplying to, this one or this one, not both. Either way, I'm doing my foiling part first, my distributive property of these two first. -4 times -3 is 12. -4 times 8 is -32 with an I on it. I times -3 is -3 with an I on it. And then we have I times 8i is plus 8i squared. Simplifying, we have -8i times, what is this going to be? 12 minus 35i, and then plus 8i squared becomes -8. Simplifying it one more time before we multiply, we're going to get 4 minus 35i. Multiply this out one more time now, -32i, and then 8 times 35 is 280. So it's going to be plus 280i squared, but that's equal to I squared is equal to -1, so that's equal to -280, or -280 minus 32 with an I on it. Gorgeous. Moving on to our last type of problem, question 12. So here we go on question 12. When you have a situation with just a letter I on the bottom and not just a plus, you can always simply multiply the top and the bottom by the letter I. So we're going to multiply the top and bottom by the letter I, and it's just going to instantly solve our problem, just like we would if we were solving, reducing a rational or reducing a radical. Reducing a radical rational, whatever, doesn't matter. You're multiplying I over I, and you'll get -8i on the top and -6i squared on the bottom. But we know that I squared is -1, so this becomes -8i over 6. Make sure you reduce and write it in that a plus bi format. 0 minus 4 over 3 with an I on it. Gorgeous. So let's move on to question number 13. Question number 13 is going to be a little different. On this problem, you have to remember to multiply by the complex conjugate. What that means is if I have a plus bi, you're multiplying by its conjugate, which is a minus bi. Has conjugate a minus bi. The whole idea here is if I multiply an a plus bi multiplied by an a minus bi, and we do our little distributive property here, we'll end up with a squared minus abi plus abi minus b squared I squared. The minus abi and the plus abi cancel, and negative b squared I squared is positive b squared. And that's what you're going to end up with when you multiply these two things together. And that's going to make your i's disappear completely. So we're going to go ahead and multiply the top and bottom by -4 minus ai divided by -4 minus ai, multiplying by that conjugate. On the top, we have no choice but just to do our first outer inner last stuff we've been doing for a little bit here. -4 minus ai plus 16i plus 32i and squared there, divided by, but on the bottom we can use our trick of a squared plus b squared, and that's going to give us 16 plus 64. We got to simplify that numerator best that we can. So we're going to have -4 And then this is going to be minus 32. So we're going to have negative 36. And then minus, no, it's actually going to be plus, right? Because we have negative 8i plus 16i is positive 8i. And this is all over 80. Let's make it two separate fractions. And now we just have to reduce our fractions. And reducing our fractions, these both divide by 4. So we're going to get negative 9 over 20. These both divide by 8. So we're going to get plus 1 over 10i. Beautiful final answer. There it is. Last but not least, we have question number 14. Find the absolute value of each complex number. All we have to do here is remember that we're basically just doing a Pythagorean theorem. This is just going to be equal to the square root of a squared plus b squared. Ignore the I completely and just go for it. So we're going to end up with, on this question, the 9 squared plus 6 squared. And that's going to be the square root of 117. When you're doing your 117, if you forgot, you got to reduce it doing this whole bad boy thing where, you divide by, what's it going to be, 13 and 9, and then, 3 and 3. There, you circle those ones, leave that one outside, and we get 3 rad 13, and we're done. Have a wonderful rest of your day, and peace out.